question number 1. It is 14th question of 2024 paper. An ideal transformer has 200 turns in the primary coil and 400 turns in the secondary coil. When the primary is connected to an AC supply of VRMS 110 volts, a current of IRMS 10 ampere flows through the RMS voltage. Through it, the RMS voltage and RMS current in the secondary are respectively given by. We can use V1 over V1 over V2 equals N1 over N2 for any type of transformer. V1 means voltage in primary coil. We can substitute 110. V2 is the problem. N1 is number of turns in primary coil. It is 200 divided by N2 is 400. Then we can simplify it and we can obtain V2 value 220 volts. If we are substituting V1 as the RMS value as the V1 voltage, we can obtain RMS value as the V2 voltage. If we are using peak voltage for the V1 voltage, we can obtain peak voltage of secondary coil by V2 value. Then it is RMS or peak value is not depending to this problem because of they have given RMS value and we have to find RMS value. Just think about that it is a voltage. Then we can use V1 I1 equals V2 I2 equation to find the current of secondary coil. But when using this equation, we have to remember that we can use this equation only for an ideal transformer. Ideal transformer means ideal transformer means there is no energy loss in the transformer. Power given to the primary coil equals to power output of the secondary coil. Then V1 voltage is 110. I1 current is 10. V2 voltage we have found 220. We have to find I2 current. Then we can cancel out 110 divided by 110 1, 220 divided by 110 2. 10 divided by 2 means 5 ampere. Then we can get 220 volts and 5 ampere. Fourth one is the correct answer for question number 1. Then second question, find the five resistors and a battery are connected as shown in the figure. The EMF of the battery is 6 volts and it has a negligible internal resistance. What is the voltage across resistor R4? Right. Now they have given 50 ohm, 50 ohm, 60 ohm, 30 ohm and 30 ohm. This voltage is 6 volts. We have to find equivalent resistance of these two resistors. There are two parallel resistors. Then we can obtain product over sum. Product over sum means 16 to 30 divided by 90. 30 divided by 31, 3. 60 divided by 3, 20 ohms. Now, equivalent resistance of this full part, 20 is resultant equivalent resistance of this one plus 30, it is 50. 50 parallel, therefore we can obtain total resistance of this part is 25 ohm. 50 parallel. Then we can find the voltage between A and B by using potential divider method. VAB equals 6 divided by sum of resistors 50 plus 25 75 multiplied by corresponding resistance 25. Then we can obtain 2 volts. And then I will use again potential divider method to find voltage between C and D. VCD means voltage between this point and this point. We can obtain it. Total voltage given to these 2 points 2 volts. 2 divided by sum of resistors 20 plus 50 20 plus 30 50 multiplied by corresponding resistance 20. Then we can obtain 4 5, it means 8 over 10. 0.8 volt is voltage between this point and this point. It is equal to the voltage input for this resistor, this resistor or total system. Now R4 resistor is this one. Therefore, we can obtain our voltage drop across R4 resistor is 0.8 volts. It is question, answer number 2 for the question number 2. Then question number 3. A current I flows to a uniform metal wire which is maintained at a constant temperature. Which of the following graph best represent the variation of power dissipation P in the wire with current I in the wire? We can get a relationship for power P equals VI, I squared RO, V squared OR. Now we have to get relationship between power and current. Temperature is constant, therefore we can consider R constant. Then power is directly proportional to I squared. It means when increase in I, power is increasing like this. There is a curve like this. When current is twice, power should be 4 times. When current is 3 times, power should be 9 times. Then we can obtain third one is the correct answer for question number 3. Then question number 4. The potentiometer wire AB shown in the figure has a length 100 centimeters and a resistance 10 ohm. It is connected in series with a resistor R and a cell of EMF 2 volts and negligible internal resistance. The balance length for a source of small EMF 10 millivolts is found to be 40 centimeters. What is the value of R? We can consider the given circuit. Length of this wire is 100 centimeters and resistance 10 ohm. We have to find this R value. Given cell is 2 ohms, 2 volts, and measuring EMF is 10 millivolts, and they have given balance length is 40 centimeters. We know that we can increase the sensitivity of instrument by using a series resistance. Increasement of sensitivity means we can obtain a small k value. We know that k value means potential difference per unit length. Potential difference per unit length. Then we can obtain, when decrease in k value, we can obtain a high L value balance length. Then we can consider that the instrument has a high sensitivity. Then we can write k value. Total, we can consider current through these two parts 0 when considering balance situation. Then total voltage for above circuit is 2 volts. We have to divide by sum of resistors 10 plus R multiply by corresponding resistance. This one is the voltage across wire. And we can divide it by 100 to obtain potential difference per 1 centimeter. Then we can simplify it. 2 divided by 2, 1, 5. Now we can get balance length. Measured voltage is 10 millivolts. It should be equals to KL. K value is 1 over 5 times R plus 10. L is 40. 5 divided by 5, 1, 8. R into 10 to the power minus 2 is this one. 10 to the power minus 2R plus 10 into 10 to the power minus 2, 10 to the power minus 1 equals 8. I will bring 10 to the power minus 1 to the right hand side. It is 0.1. 8 minus 0.1, 7.9 is 10 to the power minus 2 R. Then we can divide it by 10 to the power minus 2 and we can obtain 790 ohms. Answer is 1 for the question number 4. Then fourth question. A set of parallel resistors and a set of series resistors are connected as shown in the figure. The resistance value of series of resistors may or may not be same. Which of the following statement is always true? First one, the current through each resistor in set of parallel resistors is same. We can consider there is a same voltage for parallel resistors, but current is same only when there are same resistors, but resistors are same or not, they have not given. Therefore, we can't get first one as the answer. Then second one, the voltage drop across each resistor in set of series resistors is same. we can consider set of series resistors. For series resistors, current is constant, but we can get only voltage is constant when there are same resistors. Therefore, second statement is false. We can get third one. Then third statement, the total resistance of the entire network is greater than the resistor of any individual resistor in the set of series resistors. Yes, we can get it is the correct statement because of we know that when considering one series resistor, we have to add other series resistors to obtain the equivalent value of given series resistors. Therefore, we can consider third one is the correct answer for question number 5. It is 34th question in 2024 A-level paper.